Do you see the record button?
Yeah, it's recording. Well,
Okay.
yeah, it is.
Okay, so it's gonna like save to your laptop, and then can you just like crop it and upload it to YouTube by like end of tomorrow?
To the Cortex one, I don't have, you can give me the password or you can just upload it.
Okay, or you can just send it to me, or I'll just give you the password.
Either way works.
Okay. Or you can
Hey,
maybe send it to an Anya. I don't know.
can you present?
Okay. Okay, let's just
Oh,
like
do you
wait.
want us to show our faces when we present our hearts?
Wait, no, just everyone turn off their camera just in case. Like, I don't want it on YouTube.
Oh, okay. Okay,
Right? Okay.
yeah.
Or should we, either we all turn it off or we all turn it on? I don't know.
I
What
don't
are
care.
y'all thinking? Okay, let's just keep it like this. Okay, so let's just like be quiet for like 5 minutes so it's easy to crop. Hello, everybody. Welcome to STEM Fridays. This is the May 1st session, and first we're going to go over the creations that we got from last week. So last week we asked you guys to create a Rube Goldberg machine, which was basically getting a small ball into a cup. Let's check out some of the submissions. Yilong submitted one, Pranav, Vaibhav, and Ethan all made really great machines. Blake made one, Avery made one. Let's show Rosabella's creation. That was really awesome. Let's check out Ella's next. So the water's slowly rising and that'll hit the ball. Then the ball goes through a maze and finally it lands in the cup. That was really awesome. And lastly, we have one last creation from Simran. Awesome. Okay, and just a note for next week, you guys can send your creations to stemfridays@gmail.com using a Google Photos link. You can attach it to the email or upload it to Google Drive and share it that way. So we're going to start off today by talking a little bit about the FIRST robotics program. And FIRST stands for Inspiration and Recognition of Science and Technology. So for lower elementary schoolers, you usually start out in a program called FIRST LEGO League Junior. And in this challenge, you are prompted to build a solution to a real-world problem out of Legos and describe it to different judges. So this year's challenge was actually Boomtown Build. And you were challenged to build a building or a facility that was durable, environmentally friendly, and that was accessible to all kinds of people. And we saw a lot of the cool creations that you guys made. And if you're interested in this program for middle schoolers, it's great to join FIRST LEGO League. And there's 3 parts to FIRST LEGO League. The first is the core values aspect. So basically you get together with a team of about 5 to 10 students, and you are prompted to create a project in a robot game, but throughout all that, you have to follow certain core values such as teamwork, cooperation, gracious professionalism, and these soft skills can be used throughout your life, which is really helpful. Then the next aspect is the project. So you're given an issue in the real world and you're challenged to create a solution to it and do a whole research project on it. And this might mean going to professionals in your community, coming up with a business plan. And for example, one of the challenges was helping astronauts overcome psychological and physical issues with long-term space travel. And there was a lot of really amazing solutions that the students in this program came up with. And the last part is the robot game. And as you can see in the picture to the left, you get to create robots out of Lego Mindstorms. And you get to also program them to complete different missions across a mat and gain as many points as you can in 2.5 minutes, which is really exciting. And this is the first robotics competition, which is more for high schoolers. And this was actually our robot about a month ago at the Wake County District competition. And the challenge is basically to build a 120-pound robot in 6 weeks. And when you're not doing that, there's also outreach aspects, business aspects, marketing aspects. So it's almost like running a small business, which is really exciting. Next, we're going to talk about our activity for this week, which is building parachutes.
So first, when we're talking about parachutes, we would talk about gravity, which is known as the force of attraction that pulls two masses together. So it's not just between objects and the earth, but for this activity, we'll be focusing on objects in the earth because you'll be kind of manipulating gravity to make an object fall slower. So you'll be trying to change the force of gravity on that object. So this is an example.
And then let it go.
Whoa! That was really far, guys.
So your task would be to build a parachute, and it should hold a mass, but a light mass, such as a pencil or a ping pong ball, nothing too heavy, and you want it to stay in the air as long as possible. And when you're done with that, make sure you email a video of your parachute to stemfridays@gmail.com.
Yeah, so let's start with some materials that you could use to build your parachute. So you're going to want a lot of string, either a large piece of paper or a plastic bag. This plastic bag can be either a grocery bag or a trash bag. And then you're also going to want to have a hole puncher or a pair of scissors. So the first thing you're going to want to do is cut out a large square from either your plastic bag or your large sheet of paper. And then you're going to trim off each corner to make it look like an octagon. And then at each corner of your octagon, you're going to want to cut a small hole using your scissors or either punch a hole using your hole puncher. And try to make sure that these holes are the same distance away from each corner of your octagon so make sure that the weight of the parachute is evenly distributed. The next thing you're going to want to do is cut 8 pieces of string the same length and thread them through the holes that you cut in your parachute. And after doing that, you're going to want to tie all those pieces of string together and then tie it to the mast you're using. You can use either a pencil or like a ping pong ball or something like that. And then after you're finished building your parachute, you're going to want to find a high spot to drop your parachute. So you can either drop it from like off of a chair or off of the top of a staircase. And when you're doing that, you're going to want to time how long it takes from the moment you drop your parachute to the moment it hits the ground. So you might be wondering how you're going to make your parachute better. So you can manipulate different variables in your parachute, one of which is the string length. So a longer string length will allow for more air to get trapped underneath your parachute, which will And with more air resistance, your parachute will be in the air for a longer amount of time. The number of strings, so if you only have two or three strings, your parachute might wobble in the air. If you use more strings, like 8 strings like you're doing with this parachute, you'll have greater stability. Parachute size, so the larger parachute you have, the more amount of surface area you have, and there's greater air resistance, so your parachute will be in the air for a longer amount of time. So the shape of your parachute, so a circle or an octagon are probably the best shapes to go with, because they have lots of symmetry. And then parachute material. You guys should probably use a light material, so either paper or a plastic bag. But if you guys don't have those materials, you can experiment with using light cloths, such as if you have handkerchiefs or towel, something like that. Then that hole that you see in the picture on the right, that's a stabilizing hole. So when your parachute's dropping, there's a lot of air that gets gathered underneath your parachute, and the stabilizing hole at the top will allow an easy exit for air to come out, and it'll prevent your parachute from wobbling in the air. However, if your hole at the top is too big, too much air will rush out, and your parachute will hit the ground faster. Some extra resources. Yeah, so once you're done building your parachute, you can either take a video of it in the air or take a picture of it, and you can submit these to the STEM Fridays email. That's it.
Thank you, guys.